Well, hello and welcome to today's 18 Group webinar entitled High Performance Networks and Low Latency Connectivity for Trading. My name is Mike O'Hara. I'm an editorial contributor at 18 Group and I'll be moderating today's webinar. Before we get started, I'd just like to quickly welcome our expert panel, Luca Saman, who's the Head of Product Low Latency Group, LSEG Data and Analytics, Christopher Brown, Executive Director, Latency Sensitive Electronic Trading, LSET at Instinet, Richard Bell, Head of Engineering at CoinShares, and Himesh Soneji, Business Development at TNS. So welcome all. I'll ask you all to briefly introduce yourselves when we get started. But before we do start, just some information for our audience on how you can take part in today's webinar. To the right of the video you're watching, you'll see a box for questions and polls. We'll be running 3 audience polls during the webinar, so please do vote. It does help us gauge industry opinion and know what people's challenges are. I'll let you all know when the polls are coming up, so you'll have ample opportunity to vote in them. If you'd like to ask the panelists any questions, we will be looking at these throughout the webinar, and we'll be aiming to address as many of them as possible towards the end. So please feel free to ask your question in the box again to the right of the video. Just a quick mention of some of our upcoming events and webinars. We have a couple of events that will be of interest. One is the Trading Tech Briefing in New York on the 24th of June. Another one is the AI in Capital Markets Summit in New York later in June. And then we have a couple of webinars coming up as well, the Future of Market Data on the 25th of June and Best Practices for Managing Trades Surveillance on the 1st of July. So, without further ado, let me please hand over to our speakers, 30-second introduction from each of you. So starting with you, Luca.
Thanks, Mike. Excited to be here. Appreciate the invite. And Luca Saman, Head of Product for LSEG on the Low Latency Group side.
Thank you. Christopher.
Hi, I'm Christopher Brown. I run the Internet Latency Sensitive Electronic Trading team, which serves the quant and systematic community with market access and market data solutions.
Excellent. Thank you. Richard.
Hi, I'm Richard Bell. I run engineering at CoinShares. We are a digital asset manager. We've got Europe's largest Bitcoin spot ETF on the market, as well as a number of other products in Europe and in the US.
Great. And last but not least, Himesh. And I think you're on mute. There you go.
Hi, Mike. Thank you very much. So Himesh Soneji, I work in business development at TNS. We provide co-location, raw market data, really focus on ultra low latency access to the markets for hedge funds, HFTs, banks, you name it. My background is actually in low latency network engineering, so very familiar with this topic and really looking forward to the conversation today.
Excellent. So thanks, gents, for joining us today. I think it's going to be an interesting discussion. First of all, before we get started with the questions, could we have the first poll question for the audience up there on screen? So the question is, how has the definition, sorry, the question is, let me get to the right poll question. What is currently your biggest network related challenge in low latency trading? Bunch of different options there. The last one being other, so it'd be interesting to see if there's anything that's not listed there. But while the audience answers those that poll question, Chris, I'd like to start with you, if that's okay. I mean, how do you see the definition of low latency has evolved over time? What does low latency actually mean in today's trading environment?
Yeah, I mean, I think it serves ourselves well to kind of remind ourselves at the start of what the kind of equities trading landscape in Europe is looking like. I mean, it's complex, it's fragmented. There's a ton of order types and new order types coming all the time. Trading mechanisms and execution venues are kind of still increasing. And so beyond trading on visible limit order books and dark pools, there's private rooms and obviously the OTC space. So I think given this kind of fragmentation, it's important for us to kind of understand what the available kind of liquidity that's addressable is and how to trade kind of most efficiently with it. So, you know, in this period of time, we've seen, since really 2019, I guess, we've seen execution going from being described in the 1 to 2 milliseconds to now being described in the 100 to 500 kind of microseconds. So definitely a microsecond space, if not a sub-microsecond space. Hardware-wise, we see much more consistent utilization of FPGA and obviously ASICs for order processing. And I think here really for example, the leading brokers are using FPGAs in a number of different ways. Some using it as an FPGA feed handler alongside a C++ market data publisher. You've got it being used as a dedicated hardware component used for risk checking orders in market access products. And then you've got it in elements of C++ software for very specific performance enhancing functions. So firms are using it in lots of different ways. Some are even using it now in slightly more predictive algorithms and components of AI to anticipate those market moves based on partial data, which gives them the ability to kind of act even faster. So I think it's ever evolving, and you've seen kind of exchanges now looking at offering more sophisticated co-located services within the matching engines. So you've got exchanges offering dedicated cores, which has become pretty popular, and I think it's obviously a space that's got a lot of scope. Looking at the hardware, within exchanges or within the actual infrastructure. With exchanges offering improved cooling and power systems in some of the colo facilities to support that higher density, higher performance equipment, we're seeing the economics change, but we're also seeing firms looking at solutions that are going to help them maximize that space utilization, minimize their cost, and eke out ever kind of improved kind of performance metrics. So again, those are some of the things that have been making waves. And not a pun, but obviously specialized microwave or millimeter wavelengths have been spoken about a fair bit in the past. That's always seemed fairly kind of prohibitive at first, but the economics of it have changed. That has become cheaper. So alongside fiber and optimized fiber optic links, including hollow core fiber, you've now got better approaches for maximizing that latency optimization that you need to have. Obviously, continued software optimization continues to be the aim of the game, and we see that improving as well.
So a lot of evolution by the sound of it. It's interesting what you were saying about FPGAs and so on. We'll probably drill down into that a little bit later on in the discussion. But Luca, anything you'd like to add to what Christopher said there?
Yeah, I agree with everything that Chris stated. I think you said it well and really dove in there. And so just to take maybe a zoomed out higher level view, just to add kind of how we think about this on the LSEG side as a global market infrastructure provider, we really think about latency across a spectrum based upon our customers and their use cases. So on one side, you have the more latency sensitive use cases like algorithmic and high frequency trading and market making. And that gets really, really important as you start to think about that across all of the different exchanges globally across asset class. On the other side of the spectrum, you have less latency sensitive use cases like portfolio management and retail investing. So to truly achieve low latency in today's trading environment, it really comes down to infrastructure and connectivity. Back to kind of the challenges in that survey question. So kind of curious to see how the group responds. But that low latency profile comes with infrastructure and connectivity, and it can come with high costs. So when considering direct feeds from each exchange and market operator around the world, and procuring cabinets and rack space in every data center, and connecting all those points of presence in a low latency network, it can add up very quickly, which is why we see on the LSEG side a number of firms moving toward providers that can help and specialize in that low latency connectivity, hardware and software deployments, exchange co-locations across the data centers globally to help remove some of those barriers.
Great. Well, let's. You mentioned the poll there. Let's bring up the poll results to see what people's challenges are. And the top one with 39% there, is achieving consistent deterministic low latency. So I guess, the lowest jitter possible. Then ensuring resilience and failover, managing cost and complexity, supporting global market access, and transitioning to cloud and hybrid environments. Interestingly, no other challenges. So I guess these must be the main ones. Any of you like to comment very briefly on those results? Are they in line with your expectations, or any surprises there? Himesh.
Yeah, I mean, I think looking at that top popular vote, the achieving consistent deterministic low latency, I think that is often, the biggest concern when we're talking about things like resiliency and failover. I mean, those are fairly well-known mechanisms, especially when you're looking at things like managing cost and complexity. People come to providers like TNS to reduce that complexity and reduce that cost. That's why we're in this business. But it's important that when we are talking about a trading firm or a trading entity that is looking to reduce their latency, they've got to be sure that who they're working with is going to give them that lower jitter, deterministic latency. Is the path fixed, or is it doing like an MPLS type of network which goes all over the place? And I think the firms that are in this space are operating this, understand those complexities. They understand what causes that inconsistency and what actually causes the determinism that these firms require. So I think it's interesting that perspective. There's a bit of a worry there. I would say that my answer to that is talk to the experts like the people on this panel who can sort of guide you through that and talk about how we actually achieve those things.
Excellent. Thanks. So, Richard, I'd like to come to you next. I mean, if we look at there's always trade-offs between latency and other aspects, right? So, what do you see as some of the main trade-offs that firms face when pursuing low latency, for example, between speed, resiliency, cost, complexity, and so on, and how those trade-offs best managed?
Well, I think it really depends on the character of the organization. Before you go down a great big path of reducing your latency or building a whole new infrastructure, you've actually got to ask what kind of business you're in. So my experience before coming here was 25 years in traditional investment banks on the low latency side. And what we often found there was that firm-wide cost was often a concern, which could occasionally hamper or make harder the desire to go for low latency unless there was a really clear reason to do it. In one particular organization, they recognized, as we were talking about on the poll, that jitter was crippling the business. And what we had to do from the stack, all the way through the stack, was I spent 3 years of my life measuring, and making sure that every single piece was in line. And that does occasionally involve having to make a proper cost trade-off. When is it good enough? So cost is always a bigger concern high up. We've always failed. I would say everyone wants to, but everybody fails to put a dollar price on a millisecond. And until you can actually do that, and especially now that we no longer talk about milliseconds, we left that new rearview mirror 10 years ago. Now we're talking about microseconds. Putting a dollar price on that is very hard, especially when the true cost is client relationship rather than actual P&L many times. Resiliency and speed are not good bedfellows. So what you'll often want to do when you're going for really high speed is go for some kind of multicast network where you're basically shouting out your instructions and hoping they get listened to. And 99.9% of the time they will be listened to and actioned on in a very, very low latency manner. Whereas as soon as you go for some kind of TCP setup, you're slowing yourself down and you're restricting your new connectivity. So I think it all just comes down to what is the purpose of what you're doing? What is the main driver between what you're doing? And then you choose your architecture based on that. Does it matter if you're out for half a minute or not? Does it matter if you're picked off for 1 in every 1,000 trades or not? So that's where the trade is. It comes from the business driver, not from the technological driver.
Yeah, I'd be interested to get Lucas' thoughts on this as well, because obviously at LSEG you service customers across this latency spectrum, as you said. So what kind of trade-offs are you seeing amongst your customers?
Yeah, appreciate that, Mike, and exactly right, Richard. And just kind of back to the question, those are exactly the trade-offs firms are faced with. in their business on a kind of daily basis. It's really speed versus cost and resiliency versus complexity. And just the questions that kind of come up are in terms of speed. How fast do you truly need to be for your strategy to outperform? As per exactly what Richard said as well, can you kind of measure that? And would those additional investments in latency savings for a few more microseconds or nanoseconds really be worth it? One thing we're seeing now more than ever are firms conducting proper back testing using the most granular nanosecond level time-stamped depth of book data right from the source in co-location to help measure these types of outcomes and their impact. And then, that ability to test their strategies using high quality packet captures is really helping firms accurately assess their interactions across a broad range of market conditions, reflecting real world scenarios before committing large amounts of capital. So that is definitely one thing we're seeing on resiliency, an absolutely critical piece of protecting a firm's existing investments. The question becomes, how much additional operational complexity are you willing to take on to cover for every failover scenario? There's multiple different types of resiliency. There's geographic resiliency, there's hardware resiliency, software resiliency, network path resiliency. So these are not easy questions to answer, but all firms have to kind of address them, and the risks become very real, which is why it's all the more important as firms consider these options that they have high quality partners who they can lean on for backup across the scenarios mentioned.
Yeah. Great. Well, we've got another poll question coming up. So if we can have that, the second poll question on the screen, and that is, where is your firm focusing most of its investment in low latency trading infrastructure in the next 12 months? And again, there's a bunch of different options there. So if I could ask the audience to respond to that poll so we can see where the investment is going, and we'll move on with the questions here while the audience votes on that poll. So Himesh, like to understand from you, with high frequency trading, ultra low latency, algorithmic trading and so on, how critical is the network layer compared to other performance factors, thinking of things like compute power, dedicated hardware, like as Christopher and Luca were mentioning earlier, FPGAs, ASICs, and software design as well. I mean, how do these elements interact in building an end-to-end low latency infrastructure?
Yeah, it's a really good talking point, and it's a long one, so I'm going to try and keep it consistent.
Talking fairly brief,
quite short as I can. I think the market's evolved over the last sort of, let's say, 10 to 15 years. I think there was this, I guess, two pathways. It was this ultra low latency HFT, unless it's sub, 500 nanoseconds, we're not interested in. We're just going to do that. I think the evolution of the market, the growth in the data that's coming, the opportunities, the types of trading strategies that a lot of these firms are doing means it's actually become a bit of a hybrid between the two. So you still have these elements of super low latency, high frequency strategies that are, still leveraging ASICs or FPGAs, so on and so forth. But that is now being complemented with some of these more medium frequency strategies, which is taking huge amounts of data and doing a lot of compute with that. So to your point, where we're talking about sort of AI and GPU grids being ever present, they're not necessarily putting these GPU grids inside the colo, but they are sending them off site to a higher power, higher density types of environment to do the alpha generation. And then that's being transported back to the co-location for very fast execution. And that can be a combination of accelerated software, utilizing accelerated hardware like overclock servers, FPGAs, ASICs, whatever it is. But it seems to be a bit of an evolution where it's a combination of the two now. When we're talking about the low latency world in terms of network infrastructure, though, I think there's two schools of thought here. Really, if you're super low latency, and if you're super low latency, cost of often doesn't so much come into play. It does, but it's seen as a necessary evil. I mean, you'd be putting the exchange handle straight into your ASIC or your FPGA, right? You're not even having the switch in the layer there. But those are very few and far between. So where we're seeing, optimization in the network layer is by leveraging things like layer one technology. So at TNS, we are operating a layer one network in every one of our colos that we've got. And we've then still got a blend of a kind of higher density 400 gig backbone for more of the, and I won't call it slower, but the needs of the higher data rates, right? Where we're going up to the 100 gig, especially with what we've seen in Opera, where the expansion to 96 channels has created huge amounts of data that these firms need to take in. That can't be done on layer one, not easily, right? So fundamentally, we start to go to this place where we have this kind of separation of the ultra latency network, which is, we're allowing connectivity to and from the network in as little as 5 nanoseconds. But then we've got the sort of higher density 100 gig capabilities. So, and I expect everyone on this webinar probably knows this, but it's not a cut and dry scenario. But I would like to come back to one point, which I think, Richard and Luca, you were talking about around the trade-off between resiliency and low latency. I think, whilst I agree with you, I think the way that a organization architects their network is very important here. So as an example, from a TNS perspective, we always make sure our A side path is always the lowest latency path. So we'll always cut down the latency, get the best circuits, whatever we need. But our B side is always the diverse path, which means it's not ultra low latency or low latency even. But fundamentally, if we speak to our customers day in, day out, they would always say, that's fine. 99% of the time, your A side is going to be up. So that's fine. We'll always take that as a feed. But the chances are, if you've got a failure in that low latency path, that's going to be street-wide. Everyone takes the same circuits from the same providers. So fundamentally, if you start doing an A side, B side multicast feed over the same path from a geographic standpoint, they're both going to go. So when we speak to our customers, they're saying, yes, it might not be the lowest latency path for your B side, but at least we're still in the market. At least we've got visibility. And that's worked really well from a TNS perspective.
Yeah, that's almost more important than two very fast connections. It's the ability to stay in the market with reliability if your A feed drops off.
Yeah.
Exactly.
Just a couple of things that I would just add to what Himesh was saying there, because I think those are great points. It's a very comprehensive picture. I think obviously that the network is probably the most important element from our perspective. I think the volume of data being transmitted and the confluence of that data through that network represents the largest potential point of issues, and the addition to the latency paradigm we're all kind of trying to solve here. So the challenge with that obviously is that you control some of it, but you're also beholden to building works, to shipping, to various factors that are well beyond your control. And the list of reasons that you invariably get from underlying fiber providers for what's causing issues on any given path is frankly fascinating sometimes, because it's not as simple as somebody unplugged something. It's often as fundamental as somebody's just drilled through a cable, and that's essentially kind of knocked you out and all of your customers, and that is very difficult to predict, surprisingly. Compute power, yeah, that's moved a lot, and I think this is massively important. There's lots of changes there, and obviously, this becomes integral to some with the more HFT-like strategy, less critical for those that are more mid-frequency or StatR, but the volume and obviously also the complexity of the calculations that are being done does increase the challenge there. And I think, yes, that you can essentially do some of that away from colo in a massive data center with cheap power and the latest equipment, and essentially then remotely distribute some of that intel and some of that alpha to local colo presences. But that is a complex setup, but one which serves a purpose and serves it very well. On the hardware front, yeah, the overclocked machines is seemingly a pretty standard kind of setup, but I still think there's a purpose for generally all-purpose type CPUs that kind of give you good bang for buck, because you don't necessarily need to be the fastest in every area for every strategy. Although that's seemingly tempting, it's not necessarily economically viable. And I think you need to start with a economically viable solution first, and then kind of scale it up, passively over time.
Yeah. Thanks for that. So the poll that we ran about where firms are focusing most on most of their investments, dedicated hardware comes top there, GPUs, FPGAs, ASICs, rather than network optimization, cloud-based infrastructure, or performance monitoring or software engineering. Any of you care to comment on those results? Again, in line with expectations or not?
For me, it does. Yeah, I mean, that tracks quite well. The network optimization piece has been around longer in terms of people looking at creating those types of solutions and reducing jitter and so on and so forth, both within their own firms and the suppliers that they use, like a TNS. But where we start seeing, software only firms, for example, that are, leveraging the new capabilities of AI out there, or, understanding that the market has now changed slightly, where faster execution is going to be a big factor for reducing slippage rates and all those sorts of things. So yeah, it definitely makes sense. I think the biggest challenge that a lot of these firms have is how we do it. And, this is why people like us are having these conversations.
Yeah, fantastic. Thank you. So, Richard, I'd like to turn to you next, because I'm interested to get your thoughts. With the rise of hybrid and multi-cloud architectures, what new challenges and breakthroughs are emerging in achieving low latency connectivity? Because I would imagine that so much of what you do at CoinShares is on the cloud, right?
It is. It is. We're a cloud first organization, and what is fascinating about that poll for me is 5 years ago, I'd have said that low latency and cloud were fundamentally incompatible, and yet 20% of your respondents said that that's where they're investing, or their biggest challenge of investment over the next 12 months for low latency is. I would say that cloud is definitely on a journey. The fact that CME and NASDAQ have both said they're moving to the cloud, when, as we all know, over many, many years, one of the greatest arbitrage plays has been between CME futures and stocks on the NASDAQ, to the point that you've had microwaves and all sorts of things built. The fact that they're moving to the cloud raises many questions about the capability of the cloud and the promised capability of it. In sitting down with cloud providers, I can see the evolution of their thought, very much from we are just a compute provider to we are a capable trading partner. And the way that they're thinking about deployment and the way they're thinking about network topology and so on is very, very promising on that. So, so I'm quite excited about what's happening in cloud. I still think there's a bit of a journey to go on, but I can see the investment and the thought. But there is the question: when is a cloud not a cloud?
Yeah.
Because what we're discovering is the kind of investment and the kind of options that are being given to us by many cloud providers takes us to the point of having to work with a third-party cloud the same way that we'd have to work with our own infrastructure. And is it actually going to cost us any less?
Yeah, Richard, just out of interest, I mean, what question I've got for you is, I remember someone saying to me a while ago that the cloud providers aren't focusing as much on the financial side because it's a very tiny slice of their revenue. I think at that time it was 4% of their revenue, and this is going back some years. And the reasons that why they weren't moving into more sophisticated scenarios within the cloud was because the revenue wasn't there. Do you think that's shifted now from a perspective from a cloud provider point of view?
Yeah, that's a very interesting time horizon, because 4 or 5 years ago, I was working in one of the large investment banks and working on low latency solutions, albeit on the fixed income side, not on the equity side. And this very, very large equities house decided that it was going to put cloud as part of their agenda. But being one of these large houses, they were fairly late to the party compared with smaller, nimble organizations, the likes of which I'm working for now. Therefore, up to that point, they wouldn't have been investing in cloud. I do remember UBS in 2012 was putting workloads out to the cloud on the risk basis. And when I first heard about that, I was slightly staggered, that they would even consider doing such a thing, given that it was so complicated, and so that given that they had all sorts of infosec rules and so on about leaving intellectual property or leaving breadcrumbs behind once they've deployed their strategies and brought them back in house. So I think there have been lots of quasi-regulatory, quasi-bureaucratic things that held back some of the larger organizations for a long time from cloud. I think that has very much changed now. So the time horizon of 4 years is about right from when the sort of inflection point would have come for some of the large organizations, and we certainly get really good attention from the cloud providers now.
Mm-hmm. Anything you'd like to add on that, Luca?
Yeah, for me, this comes back to that latency spectrum and thinking about all of the different use cases across that spectrum. I don't think cloud is there for ultra low latency use cases. I think it's come a long way, and it can continue to we'll continue to see significant improvements over time. But cloud has certainly become an enabler for LSEG. It's enabled centralized storage of massive amounts of data without the burden of maintaining on-prem infrastructure. It's also enabled the ability to tap into a global network, maybe not an ultra low latency global network, but a network nonetheless, very efficiently with as little as an internet connection, removing some of those localized information silos and reducing delivery challenges. So we continue to be excited about the future of cloud, and we'll continue to look to unlock those benefits going forward.
I think there's a point that could be made. Sorry, Mike. There's a point that could be made from what Luke was saying, that the consideration that cloud is not for ultra low latency. Well, then you ask the question, why are NASDAQ and CME moving to the cloud? And then you look at the whole market structure now in the fixed income world, especially in the FX world, which was the most low latency of the fixed income instruments I've dealt with. There was a decision and a discovery that the barriers to entry for new participants was just too high because of low latency requirements. So therefore, does it benefit the exchange or benefit the other providers from putting in some kind of latency floor? And that's the point at which, you ask, is the tail wagging the dog here? Is cloud enforcing this kind of move, or is it actually good for the market to be ever so slightly less low latency?
Interesting. And that's
and Richard, it comes back to the point. It's all relative, right?
Yeah,
it's all relative.
Yeah.
So.
If you're being chased by what was it? If you're in a bunch of people being chased by a lion, you don't have to be faster than the lion. You just have to be faster than the other people, right? So that's moving on. Just coming back to something you were talking about earlier, Himesh, about the network layer. I'd be interested to get your, and this is a big question to answer in a very small time frame, but in terms of best practices in network architecture for reducing the jitter that you spoke of and improving that determinism, especially during periods of high volatility. What should firms be thinking about that maybe you can highlight here?
Yeah, I think, particularly when we look at the US markets, I think when you're designing a network, over capacity, right? You almost double the capacity of what the market's going to be sending in, because it's the microbursts. That's the key thing. So when we're talking about the market from a market data perspective, it's large, but it's fairly consistent throughout the day. However, it's the little peaks and troughs that we see, which can overrun the infrastructure, where all of these switches, all of the routers, whatever it is, servers have got memory, and they need to soak up that pressure. So it's about architecting the right components in the right place to make sure that those bursts and that pressure can be consumed. Things like the basics, making sure that you're cutting down the cable length, don't have one server with a 3-meter cable and one server with a 1-meter cable. People that are in this industry know what they're doing, right? And they know those extra cable lengths make a difference, or how they are connected into the system all makes a bigger result into the underlying trading architecture. So, it's looking at those things when we're talking about diversity, making sure that you are entering the colo in the right points. If you're getting a circuit in, making sure they're not coming in the same point in the building, they're going into different meet-me rooms, so you can make sure that a failure in one part of a co-location doesn't going to impact and take you out of the market. And it's also about making sure that when you've got exchange handoffs, capacity monitor, making sure that you're not going to be, breaching the sides on that 10 gig connection, 40 gig connection, whatever it is to the exchange, making sure you've got a clear line of sight of the traffic flowing through it from a capacity standpoint, and making sure you're putting the right provisions in place to stoke up the pressure as the market grows and evolves. It's those are the key things really that start to impact organizations when they don't think about those things in the right way. And I think we've all been at the mercy of this. The business will want something put in very, very quickly. Get it in fast as possible. We need to upgrade this. We need to get this in. With business needs, there's going to be a quick reaction to get those needs and to realize that trading alpha. However, from an architecture point of view, it's important to revisit those things and make sure you remediate any shortcuts that may have been put in place. From a TNS standpoint, we're very adamant that we don't make shortcuts. But from a trading organization's point of view, they have to be more nimble because they want to connect to a market very quickly. So they've got to make some shortcuts in some situations, but remediation is a key part of that. And we have to make sure you have to go back to remediate those things.
Excellent.
Yeah.
Thank you.
And with the luxury of time, I mean, you can plan things obviously much, much better. But as Himesh said, sometimes you're faced with a short-term business opportunity and you've just got to slam something in, and it'll work and it will function well, but it won't necessarily be scalable for kind of April-like volumes that come, a little bit out of the blue. The way that we kind of handle this is we at Instinet use cut-through switches. We look at FPGA-based NICs. We look at PTP hardware, timestamping as best practice to kind of optimize for minimal jitter and kind of maximum determinism. But there's a number of tools. There's a number of kind of disciplines and processes that we need to have internally to implement and then review and then optimize and then look to kind of scale things up over time. But it's not a kind of it's not a one-stop shop. You need to kind of continually look at how you can eke out performance differences and whether that's looking at the hardware, whether that's looking at the cabling, whether that's looking at doing things yourselves or with partners. There's always multiple options, and just the thing is not to be too kind of fixated on what you think is best practice, but actually continue to get second opinions and validate your own views and see whether that really is the latest best option for you based on the cost and the potential risks of it.
Yeah, excellent. Thanks, Chris. So I'd like to run the third poll question, if we can get that up, please. Which markets do you expect to spend the most time and resources on as it relates to low latency trading over the next 12 to 24 months? And we've got a list there of US options, US equities, futures, FX, and so on. So again, we'll let the audience respond to that while we'll talk for a couple of minutes about cross-market connectivity and different markets. So coming to you, Luca, I mean, what are some of the best approaches for cross-market connectivity? So accessing liquidity across multiple regions and multiple asset classes, including, for example, digital and crypto. And I'll be interested to get your thoughts on this as well, Richard, while still maintaining those latency and performance benchmarks.
Yeah, and again, I'll answer this from the LSEG perspective as a global market infrastructure provider. So just again, briefly, because of our position in the market, we connect to all of the markets around the world across asset class. And what really excites me about this topic is getting to see what those capabilities kind of unlock in terms of global opportunities for our customers. So as you look at the proliferation of U.S. equity exchanges and U.S. options exchanges, and then the markets across the Asia Pacific region, everything that's going on, and just a lot of activity in Korea and Japan and Australia. So continuing to kind of monitor that and see that, and again, as customers think about new markets and new opportunities, whether again India or Korea or any of those places, it's kind of fascinating to watch as the provider who can enable that global network for our customers.
Mm-hmm. Richard, this is something that's fairly close to your heart, I would think, in terms of accessing liquidity across different asset classes, including digital.
Yeah, very much so. If you're working in digital assets, you're going to be accessing liquidity from traditional equities markets, from futures markets, from retail-focused and institutional-focused crypto markets, and the geographic dispersal is truly global. So from Japan to Hong Kong to Frankfurt to London to parts of the US, and you've got to manage potential opportunities across all of these regions. There's no substitute for having really good interconnects and figuring out the best and fastest path to each exchange and the best place to deploy strategies. At the end of the day, it's a matter of working out, again, what your business is and what your strategies are going to look like to optimize this. There's a lot of work that everyone's talking about getting networks down to the microsecond, but that's kind of academic when you've got a 230 milli round trip to one of your exchanges to put it off against something else. So you do the best that you can. Determinism inside your software is also very, very important here because that's something that you can control. So making sure that you don't get outliers, you don't get spikes in your own internal latency, doing the very best you can with the tools that you can change.
Mm-hmm. Thank you. Anyone else got thoughts on that? Himesh, did you want to add something on that, or?
No, I mean, I think when we're talking about cross-market connectivity, I think, we mentioned earlier the evolution of wireless. I think Christopher sort of talked about the wireless sort of parts becoming more economically viable for the organizations out there. And we see that as a growth, right? I think when we are looking at that world, the New Jersey Triangle is metaphorically lit up with microwave and millimeter wave parts all over the shop. And I think it was cost prohibitive. It is getting better. I think the technology has got better now as well from a wireless point of view. But again, it comes back to the resiliency and consistency of it. Wireless and millimeter, generally is, whilst it's not as bad as it used to be, it is still susceptible to sort of weather patterns and rain and so on and so forth. So understanding of having sort of a fiber arm between your wireless and your fiber path to make sure that trade executions and signals are getting through. Some of the providers are now providing market data over wireless, and sometimes that works, sometimes it doesn't. But really, from my understanding, what I think if you're doing a typical futures lead from, let's say, Chicago to New Jersey Triangle, really you're doing signaling, right? You're not sending the market data across. You are watching what's happening at very low latency in CME, as an example, and you're creating a very, very small signal to send across the wireless, and you'll send that multiple times to make sure that the endpoint can get that message and make a corresponding trade execution. But lastly, I think we are somewhat helped, I think, by these liquidity pools and exchanges co-locating in the places where others are as well. I think most people want to be in NY4, and most people are going into LD4, and I think they want to be there because most of the clients are there. But that helps the client base because it means that we don't need to now worry about connecting out to somewhere in, I don't know, Spain outside of the BME, as an example, where a liquidity pool might be sitting. So those kind of decisions that businesses make help the wider trading community to keep costs down, but also to keep that jitter and consistency fairly solid.
Excellent, thank you. So can we get the poll results up, please? This one doesn't really surprise me, actually, but I'd be interested to get the panel's thoughts in terms of the markets that firms are spending their most time and resources on, and that's futures as opposed to US equities, fixed income, or US options or other markets. Any surprises there for anyone?
I'm surprised no one's saying crypto. And you do a little bit of research, you'll see that that's a very dynamically changing market that's going that's becoming more and more about Bitcoin treasury companies and ETFs. So more and more liquidity moving onto quasi equities markets. That's somewhere a place where people need to be investing, because
Yeah.
that's going to be a great big market shift.
Yeah, interesting. I guess the question, maybe it's the way the question's phrased in terms of which markets you expect to spend the most time and resources on.
I would love to see actually someone putting up here that they're going to be spending money on quantum entanglement. That'll solve
Okay.
lots of your cross-region connectivity market data issues.
Maybe in a few years' time we might see that one. Yeah. Okay, I'd like to take a bit of a pause here and look at some of the audience questions, because we've had a few questions coming through from the audience. It'd be nice to try and attack some of those if we can. So, and then we will come back to the kind of pre-arranged questions afterwards. Let's have a look. Is it worth diving into software-defined networks, or are these actually causing more trouble than value added? Software-defined networks in terms of low latency. What anybody's thoughts there? Mutually exclusive?
It's interesting. It's so I think about 8 years ago is when really Cisco came out with it and said software defined, it's all going to be seamless to the underlying architecture, where people like me at the time that were typing in conft and router VGP and all those sorts of things. I think it depends on the control, right? We talked about consistency in the paths, making sure that the rules that govern that selection of a path within the network are being adhered to. From what I kind of would envisage, I think because the traffic and the trading traffic that's going over there is so important, I would feel a lot of organizations would take the angle here to say, I would rather pin that, by manual configuration, and not leave that up to an algorithm to decide which way my traffic should be taking. But, I'll be interested to hear others' opinion on this as well.
Anybody else want to pitch in on this one? Maybe not. Well, we can move on to there's an interesting question here from John Colborne, Edge Networks. Firstly, what are the panel's views on the relevance, effect, and outcomes of implementing White Rabbit technology, both in hardware and across networks, to achieve and support low latency aspirations and real world needs? Now, this is the first mention of White Rabbit on this this webinar. So, who'd like to take that one?
I'll give it a shot.
Go for it, Himesh. You go for it.
I don't want anyone to get fed up with my voice. That's why I'm trying to give other people an opportunity. So, look, the White Rabbit technology is actually fantastic. It's really good technology. Organizations have been deploying it quite widely, actually. So, TNS have actually got some implementations of it as well within our network. I think it really depends on how accurate do you need it to be, right? I mean, a lot of organizations are happy with just PTP signaling from the local co-location. But when we are starting to look at distributed networks and distributed points of access into liquidity pools or, market data scenarios, how accurate does that time of release need to be? And then when we start looking at, that the deviation of one PTP feed versus another PTP feed from two different sources, albeit they are, time synchronized to GPS, but fundamentally they're still two different GPS sources. And there is, in the normal traditional PTP, there's no kind of check between the two of which one is accurate and which one's slipped. So that White Rabbit technology is really good at that, just keeping that wider global network honest in terms of its time synchronization. So, I think it's growing in its importance, but it's, again, looking at, does the application need that level of accuracy from the timing point of view? And I guess that's a point of view thing of what your business does.
Yeah, thank you.
I think it makes sense.
Yeah,
not being particularly familiar with White Rabbit, if you can't measure it, you can't fix it, and you can't improve it. And in previous latency reduction exercises I've been involved in, one of the biggest issues was just getting the measurements right, and getting these signals to line up, and getting your measurements honest. So whatever enables us to measure and make it better, that's a good thing.
Excellent. So, Chris, moving to you. Earlier on, you were talking about FPGAs and how they're used in different ways. So I'd like to kind of maybe explore that a little bit in terms of obviously technologies like FPGAs, smart NICs, and so on. They're well proven, have been used for some time now in low latency trading, but not all firms deploy them in the same way. So what do you see as being some of the key considerations when deciding how and where to use these components?
Yeah, I'll try not to repeat myself from earlier on, but I think it does come down to that kind of spectrum. So really, how critical is the absolute kind of minimum latency that you need for your particular strategy? As some strategies are particularly latency sensitive, and many others are not. I think it also depends on the complexity of the underlying algorithms. Some of them are simple enough to be, fairly efficiently coded to in software. Others might need that to be in hardware. Obviously, software comes with a bit more flexibility, and the resources to do that software development are a little bit more readily available than on the FPGA side. But they're kind of fairly important considerations. I spoke a bit earlier on about the kind of cost-benefit analysis of hardware, given that both the FPGAs and NICs can be fairly expensive to acquire, program. But I think firms kind of need to weigh this against the expected performance gains they're going to get, because you don't necessarily get the same gain from both, but that gain that you get is potentially satisfactory and could be achieved in software at a slightly lower cost. So the operational costs of doing that work and then potentially operating that kit in colo, the space needed for it, the power, the cooling, and the maintenance of it, I think are fairly kind of integral also. Thinking about the kind of human side of it, there's obviously a degree of expertise and resources required for this. So, if you're looking into, programming an FPGA, then you need to have the appropriate skill set in VHDL or in Verilog. Now, they can come from various different industries and be applied into the financial industry, because essentially it's a technical role, and that role could come from automotive engineering to aeronautical engineering and be applied to finance. But you need to ideally have the right skills first, and then the right training. But obviously, FPGA development isn't necessarily that quick compared to software. So you just need to kind of factor up the time to market and the costs for the ongoing support of that. Software, I guess, is also generally easier to update than FPGAs. So I think that can have a fairly kind of material impact. But obviously, once an FPGA is in, it's pretty stable. It's going to be good at handling the more latency critical functions, and you can kind of leave some of the more dynamic software work to software applications. So, typically most of the time we see it being used in market data processing, where they pass and filter market data at line speed and kind of reduce some of the load on CPUs. Yeah. We see it for order execution, where they generate and send the orders with low latency, and then the risk calculation side of things, which is both again done in kind of real time, and then for network stack acceleration. So you've got different implementations with different use cases. You don't necessarily need to use FPGA in every element, or software for that matter, and you can essentially use a kind of a combination. But I think the things you might want to factor in and not forget are on the regulatory compliance and auditability side of things. You need to ensure that your FPGA systems are adequately auditable, because I think that can potentially become a point to kind of trip you up on. You need to have the appropriate testbed tools to be able to accurately simulate FPGA performance in the trading environment. And then, we've spoken about the cloud, and there has been talk of FPGA as a service or cloud-based FPGA solutions. I haven't looked into that specifically to see how actually viable they are, but as a concept, that's potentially something that might reduce the time to market and reduce the cost of kind of getting into that. So I think those are some of the main things I'd look at.
Yeah, the one thing I'd add to that is actually just a very important point that Christopher mentioned, and that is the human cost. It is not easy especially if you're moving from a software only to even elements of a hardware driven strategy like FPGA, that there is a huge cost there in terms of intellectual needs from the people that work for you, understanding, do they understand the market? Are they going to be able to convert that into a strategy that can be used in the market? In my previous lives, I was working at a FPGA firm like this, and we used to see that actually when a organization, they would have hardware level developers on staff, but from the time where they pull the trigger and say, we're going to go and do this, to when they go live, it can often be 6 to 9 months. It's because there's so many things that need to be considered, so much verification, so much testing. So, it's worthwhile doing this, but you have to go in with your eyes open. Don't think it's going to be something you can spin up in 6 weeks' time. It's going to take some time to put it in, and you need to put the right planning and resources around it.
Yeah, thank you. I'd like to pick up on another audience question actually, because it goes back to what you were saying earlier, Richard, about if you can't measure it, you can't fix it, kind of thing. And so the question is, what kind of network telemetry and real-time monitoring tools do you use, not just for troubleshooting, but for proactive performance optimization? So anyone like to pick up on that one in terms of the tools you use for telemetry and so on?
Yeah, I'll take this one.
Thank you.
Obviously, that is critical. If we're not able to see issues and be able to communicate issues and failover steps to a client, then obviously we're at a disadvantage. So it's critical that we're able to do that. So we have a number of both internal applications that really kind of look at the packets and third-party systems that allow us to monitor the performance of all of the connections, both across the entire network and stack, both at a hardware as well as network level. And we essentially look at a traffic light type system throughout the day. It's in our line of sight. It's 1 degree to the right of the main thing that we're looking at, and it essentially allows us to see the exchanges, the routes, the clients, the impact, and whether they're on primary or secondary, and essentially allows us to communicate that to clients so that there is a full knowledge of what they're on, what they've been moved to, what the potential impact is. But where we're looking to take this now, and I hate to use another buzzword, but we're looking at kind of tooling around AI to look at the history of the issues that we've had, the history of our experience with that particular client, that particular network, or that particular exchange, as well as what we can gather from the internet more generally, and look at any kind of indicative guidance that we can get of the symptoms of potential issues that might be kind of ruminating, so we can get an early indicator of things that might be coming along.
Great, thank you. We're kind of running out of time now, unfortunately. I just looked at the clock and we've got kind of 2 minutes left, which is this. I mean, there's so much more that we could discuss on these topics, and we haven't even touched on things like regulatory requirements and market structure changes and so on. But to wrap up, if each of you can give me like 30 seconds looking ahead, what's on your radar in terms of future-proofing network infrastructure for trading, and what might surprise the industry in the next 12 to 24 months? And I'll come to you first, Richard.
Well, 12 months is a long time in the market. Anything could surprise you. I think certainly on our side in the digital assets world, we've had plenty of significant changes in the last year. I think we're going to be trying to keep up with what's happening in the wider market itself and its market structure. And that is going to involve, on our side, lots of moves of our digital asset space to the equities markets, which means that we are going to have to rethink the way that we access markets and the way that we interact with markets and the way that we build our software and our strategies.
Excellent, thank you. Himesh?
I would say the biggest thing is data consumption, right? Both in the historical data sense and the real-time scenario. I think a lot of these strategies are going to be evolving with sort of more sophisticated algorithms and looking at a deeper and longer reaching data set for given markets so that they can actually generate alpha not on a day or a minute, but even in the second or the millisecond. So we'll start seeing those strategies evolve. I think going back to your point, the audience question around measurement, I think that's so important. If you can't measure it, you can't verify it, right? So, there's going to be a big push within the industry, particularly around the service provider space, in providing that. I do think that comes with a bit of caveat, though. When you are using providers, how much visibility do you want to give providers to your trading traffic? So I think there's a delicate balance there to be struck. So, those are the things that I think will continue to evolve over the next 12 to 24.
Thanks. Chris, very briefly.
Yeah, very briefly, 2 points really. I guess the main one is that as the FPGA development, process is becoming more challenged and being able to eke out the performance getting harder and harder, I think, we'll see photonics, become slightly more interesting and even more of another buzzword. But I think that might be an area where, we'll see some developments. And then I'll end on a slight bombshell and talk about the fact that, data centers themselves are potentially going to be challenged. We saw obviously significant power issues at Heathrow just 3 or 4 months ago. That's not terribly far from Slough. And even though Slough had plenty of power and was able to kind of wasn't affected by those issues and would have been able to mitigate those issues. But it is a factor. Power in the UK is a factor. These data centers consume a huge amount. Clients are asking for ever more power in those centers, and I think that might be something that we'll need to factor. And if those data centers subsequently become, critical national infrastructure for the UK, then that could be potentially interesting.
I just saw in the news today about the renewed investments in nuclear power facilities. So we'll see what happens there. Luca, last word to you.
Yeah, no, data center space is a huge factor and going to continue to keep a close eye on that. Additional market fragmentation, just add another, already 16 U.S. equity exchanges, 18 U.S. options exchanges. Those are more in the queue. So continuing to proliferate. Looking forward to a lot more conversation around Opera, ever increasing bandwidth requirements there as it relates to future-proofing the network. And then I'm excited to see what comes of 24-hour trading for U.S. equities. We further prepare for that. Growing demand on that trading session and in support of our customers at LSEG.
Excellent. Well, thanks, Luca, and thanks all of you for a really interesting, informative discussion. I mean, we only touched on a number of things there. We could kind of drill down in a lot more detail if we had more time, but we've only got an hour. So thanks all for a great conversation. And a special thank you to LSEG Data and Analytics for sponsoring today's webinar. Just before we close, just a quick recap on our upcoming events and webinars. We've got the Trading Tech Briefing in New York on June the 24th. Should be an interesting day. And then a couple of webinars coming up, the Future of Market Data on the 25th of June and Best Practices for Managing Trade Surveillance on the 1st of July. That's pretty much it for today. If you want to find out more information about our upcoming events and so on, if you go to the events page on our website, ateaminsight.com/events. I'd like to thank Luca, thanks Chris, Himesh and Richard, and to all of our audience for joining us today. Just one quick word before we go, that you'll see a survey on your screens. Please do complete our feedback form. We're always keen to hear your views. So thanks, gents. Thanks, everybody. And see you next time.
Thanks, Mike.
Thank you.
Thanks, Mike.